In this practical, we'll be implementing a substring index for a text t, which we can use to match a pattern against it. So in order to do this, I'm going to import a Python module called bisect, which allows us to do binary search on a list. And what I'm going to do is I'm going to create an index object. And this object is going to have two methods. The first is going to be just the initialization method, which preprocesses the string. And second is going to be a query function. So first I'm going to create this function init. I'm going to pass in a text t and a k-mer length k. I'm going to start by defining a few class variables. So I'm going to set k to be equal to the k that's passed in. And I'm going to create a list for the index, which is going to start off as an empty list. And now what I'm going to do is I'm just going to loop through my text t, and I'm going to take every k-mer of length k in that text, and I'm going to add them to the index along with their offset. So I'm going to say for I in range up to the length of t minus k plus 1. So this will give us every index such that the k-mer doesn't run past the end of the text. And then I'm going to append to index the k-mer starting at I of length k. And I'm also going to add on the offset I. And I've put these in parentheses. This is a tuple in Python, which is just two associated values. And then when all this is done, I want to sort the index so that it's easy to look up.
So in lecture, the way we described this was we were keeping the list in order as we were adding items. This time we're just going to add them and then we're going to put them in order at the very end. So this sorting step might take a long time, right? If we have a very long text t, we might have a lot of these pairs that we have to sort. But this is time well spent because we're going to be able to reuse this same preprocessed text over and over again for each query.
Yeah. So once we've created this index object and all the preprocessing has been done, we're going to create a function called a query, which we can call. And this function takes an argument p, which is a pattern that we're going to match against the text. So the first step is to just find the first k bases of p to look them up in the table. So I'm going to say k-mer equals p up to length k. I need to do self.k. And now I want to find the first position in the list where this k-mer occurs. So I'm going to use bisect to do that quickly. I'm going to say I equals bisect dot bisect left. And I pass in the list that we're searching for, and then the object that we're searching for. And remember, this is a list of tuples, so I'm going to pass in the k-mer, and then I'm going to put -1. And this, since all the indices in the list are greater than -1, this will ensure that we always get the first occurrence of that. So now I'm going to just create an empty list for hits, which is where this k-mer occurs. I'm going to say I'm going to start from I in our index list, and I'm going to just keep looking in that list for all of the entries that have the k-mer we're looking for. So while I is less than the length of the index, I'm going to say if that location in the index is not equal to our k-mer, then we're done. We've passed that segment of our list. Remember that our list is sorted, so all of the k-mers of the same type will be together. So once we find the one that's not equal to that, we can just break. If it is equal to that, then we want to append that index in t to our list. So in this case, I'm going to get the second value of that tuple and append that to our list of hits. And then I'll increment I. And when that's all done, I just return hits. And so hits will be a list of all the indices in t where p matches, or where the first k bases of p match. Mm-hmm. So now let's use this object to actually match a full pattern against the string t. So I'm going to create another function, query index, which is going to take a pattern P, a text T to match against, and an index which has been created from T. The first thing I'm going to do is just get the length of K from that index. I'm going to keep a list of offsets where it matches. I'm going to say for I in index.query P. Remember, the query function returns a list of possible places where P could start. It returns a list where the first K bases of P match the first K bases of T. But we still have to check that the rest of P matches T in that location. So I'm going to say if P from K to the end, so this will take the rest of the bases after the first k-mer, matches T from I plus K to I plus the length of P, then in this case our P matches T exactly at that point. So we can just append I to our list of offsets.
So this is what we called verification in the lectures. We're just verifying that this index hit actually is at a place where P matches in its entirety.
Yeah. And so once we've done this, all we have to do is return our list of offsets and we're done. So let's create a simple text and pattern to match against. I have this one, so P actually matches against 2 places in T. And so the first step is I have to create my index. And I have to pass in a k-mer length. I'm going to make this less, it has to be less than P, so I'm going to do a k-mer length of 2. And then I'll just run my function query index and pass in P, T, and my index. And the output is 2 indices 7 and 14. We can just verify by printing the value or the substring of T that there's a correct match at both of these places.
Yep.